What's up, people? Good to be with you today. This lesson is an extension of scientific notation. It is the scientific notation application notes. This is how you apply scientific notation and why we do what we do with these problems. The page is not that long, and as you can see, the video is not that long. It is a supplement so that you won't miss these problems on your quizzes. So, let's get into the problem. So good to be here. So good to that you are here as well. It's gonna be a good video. Can't wait. All right. Last year, Bryson's business made 2.3 times 10 to the fifth power dollars in income. This year, the business earned 3.45 times 10 to the sixth power dollars in income. This year's income was how many times larger than last year's? Show work and answer in a complete sentence. How many times larger? This phrase of how many times larger deals with, there's the bully, deals with how many times larger deals with division. You don't have to write this down, but if I say 10 divided by 2, basically you're saying how many times does 2 fit into 10? And that's 5 times. Okay, so that's where the whole purpose of division comes from. You're asking how many times does the denominator go into the numerator? And so when you're asking how many times larger than last year's, this year's income is how many times larger than last year? Well, this year's income is 3.45 times 10 to the 6th. And then last year's income was 2.3 times 10 to the 5th. So just like you were taught when you're looking to divide, you divide the numbers. 3.45 divided by 2.3, it gives you 1.5. And then times 6 minus 5 is 1. So if it doesn't say leave it as a leave it in scientific notation, it doesn't say anything. So if you multiply 1.5 times 10, you'll get 15 times larger. How show your work? So Bryson's business, goodness gracious, business made 15 times more money this year. All right, number 2. Write the following numbers from least to greatest. So we're going to use some deductive reasoning. Anything raised to the negative power, we learned from the video that negative means that the number gets smaller. So the larger the negative, the smaller the number. So this has to be the least number. Okay? Anything that's negative has to be the least number. Okay? That has to be the next least number. So we're looking at 2.1 times 10 to the second and 0.21. Okay, so we know that this number is going to expand to the right twice, so that's going to be 210, and we know that 210 is actually smaller. Oh, ho, Mr. O'Neill, I did not see that negative sign. Goodness gracious, going too fast. Any negative number is the smallest number because any negative number is smaller than a positive number. So that's 1, and then this will be 2. Almost got me. No, not today. And then the next number is between 210 and 0.21, and we know clearly this is 3 and this is 4. It would have been clear the last time if I saw that negative sign, but life. The older you get, you start missing stuff. All right, company spends a total of $675 million on salaries for its workers. If the company has 1.5 times 10 to the 4th power workers, what is the average salary per worker? Show your work and answer in a complete sentence. So this is where I insert the tool of compatible numbers. So many times when people see these numbers, these larger numbers, they get so confused. And I always use 10 and 5. That's That's what I use. I just find the biggest number, I make that a 10, find the smallest number, I make that 5, and then I ask myself, what would I normally do in this situation? So the larger number, I'm just going to make 10 right here, and this number right here, I'll make 5. So when I read this, if I say a company has a total of $10 on $10 worth, well, $10 on salaries for its workers, spends, I was like, has. A company spends a total of $10 on salaries for its workers. If the company has 5 workers, what is the average salary per worker? So you have a total of $10 and you have 5 workers. It's pretty much asking how much does each worker get. 10 divided by 5 will give me $2. So I make compatible numbers whenever I'm confused about what should I do mathematically. I find the bigger number, make it 10, find the smaller number, make it 5, reread the sentence, get the numbers in my head, and now I just do the work. So I'm going to turn this into scientific notation. It doesn't say, but that's what I'm going to do. This is a scientific notation lesson. That's 3, that's 6, 7, 8. So that's 6.75 times 10 to the 8th power over 1.5 times 10 to the 4th power. So 6.75 divided by 1.5 is 4.5. I gotta get rid of him because he's gonna come back. Gives me 4.5. And then 10 to the 8th divided by 10 to the 4th. Subtract those, you get 10 to the 4th. So 4.5 times 10 to the 4th power is going to give me 45,000. I don't know if I showed y'all the trick in the video or not. I don't know. That video's old. That's why the handwriting kind of sucks. All right, so show your work and answer in a complete sentence. What it's asking, the company spends an average of $45,000 per worker. All right. So number 4, it says a plant grows. Oh, we got 2 problems left. A plant grows at a rate of 0.04 centimeters per day. At this rate, how much will the plant grow in 4.3 times 10 to the 4th power days? Show your work and answer in a complete sentence. So again, weird numbers to me. I make the larger number 10, make the smaller number 5, and I just read it again. A plant grows at a rate of 5 centimeters per day. At this rate, how much will the plant grow in 10 days? Okay, so that means multiply. That's exactly what this means to do. If I have 5 inches per day, 10 days, 5 times 10 gives you 50. So I'll take the 0.04 and multiply it by 4.3 times 10 to the 4th power. So what I want to do is change 0.04 into scientific notation. So this is less than 1, like I said in the video, and it's not about moving left or right. This is less than 1. I move to the right twice because I need to turn this into scientific notation. So this becomes 4.0 times 10 to the negative 2nd power. So I'm doing this times this, 10 to the 4th power. So 4.3 times 4 gives me 17.2. And then 10 to the negative 2nd power times 10 to the 4th power. We add those, gives me times 2. But everybody, the multiplier is greater than 10. So we actually need to take, remember give and take. Bye, buddy. Take that and you need to give there. So this now becomes 1.72 times 10 to the 3rd power. But Mr. O'Neil, why we gotta do that anyway when you're gonna turn it into standard form? Because I want to make sure you practice scientific notation. That's the only reason why I'm making you do this. All right, so show your work and answer in a complete sentence. So the plant will be, I'm gonna leave it in scientific notation, 1.72 times 10 to the 3rd power, what's that unit, centimeters tall in 4.3 times 10 to the 4th power days. See what I did there? I made it work. All right, suppose that a scientist estimates that every square mile of the ocean contains 4.6 times 10 to the 4th pieces of trash. The area of the Earth's surface that is covered by the oceans is approximately 1.2 times 10 to the 8th square miles. Using the estimate, how many pieces of trash are in the Earth's ocean? Which is the larger number? 10 to the 8th power. So yeah, we'll make this 10 and we'll make this 5. And now let's read it again. Suppose that a scientist estimates that every square mile of ocean contains 5 pieces of trash. The area of the Earth's surface that is covered by ocean is approximately 10 square miles. Using the estimate, how many pieces of trash are in the Earth's surface? So if the total area of the Earth's surface is 10 square miles and there's 5 pieces of trash in every square mile, then I'm going to multiply. So I should take these numbers and multiply. 4.6 times 10 to the 4th times 1.2 times 10 to the 8th. Multiply the multipliers. 4.6 times 1.2 gives me 5.52. Add the exponents times 10 to the 12th power. So your answer has to be A. Oh, that was exactly 11 minutes. Y'all see that clock? Exactly 11 minutes. All right, that's the application. There will be problems that, if y'all use my trick and be like, I didn't know you're supposed to divide. Did you make your numbers 5 and 10? Smaller number 5, larger number 10. You would have known that, you need to divide those numbers. Oh, you need to multiply those numbers. I'm good. You good. We're good. We're all good. And, now we got scientific notation and the applications problems done, and we're good to go. It's been another Beast Mode Productions. Have a great day, everybody. Bye.